going to have a lot of errors. Okay, so where's that function? There it is. Okay, so I have to complete this method here. So I am going to create my prompt, which is the use case that we mentioned. And then we're going to tokenize, which is, we're going to use the tokenizer, which converts prompt to model understandable token ID. All right, so now we have our tokenized function. And what this does, hold on a second, this doesn't look correct here. Okay, so formats and tokenizes my examples for the supervised fine-tuning that we're doing. So this function is crucial for processing the data set before processing it into model for fine-tuning. What it does is structures the conversation into clear prompt format, uses the tokenizer to convert text into token ID that I showed in the Jupyter, and it prepares the labels for supervised learning, where the model learns to predict the output token by token. Up ground truth for supervised training. Set that up. This, what we're doing here is creates the labels field used during the training for last computation. Labels will be must be same shape as input ID. And during the training, the models will try to predict each token in labels based on the tokens and the input IDs. Okay, so just a note about supervised fine-tuning. The labels are the same as the input ID. This allows the model to learn to predict the full response. This is why this is important. In language modeling, the model is trained to predict the next token. So input ID map to labels. Okay, and then let's return the tokens. All right, so now we have our, let's deal with okay. So before we get into the quantization, which is next, what we're gonna do is set up quantization next, which is using bits and bytes. Quantization is the process of reducing the precision of the new numbers used to represent the model's parameter, like weights activation, from high precision, for example 32-bit floating point, to lower 8-bit integers. Why do we use quantization? Well, there's some benefits. Smaller model results in smaller models, faster interpretation in inference, low power usage, and storage savings. A few types of quantizations are post-training quantization, and this is done after training. Simple or may degrade accuracy if not calibrated well. Fast and useful for quick prototyping. Quantization aware training, quad, simulates quantization during training, helps model learn to compensate for quantization noise, provides better accuracy. And some of the common precision types are like format float 32, and as you go float 32, float 16, float 16, int 8, int 4, as it goes down lower and lower and lower from 32 bit, 16 bit, 16 bit, 8 bit, 4 bit, as that goes lower, it's the compression gets higher, and obviously faster processing, etc. So, all right. So at a high level, we're going to be getting into using LoRa, QLoRa. And we're definitely going to be using the bits and bytes and PEFT for quantization. First, we're going to check to make sure we're going to use PyTorch. We're going to use PyTorch. So I'm using PyTorch here to check if CUDA is available. I know it is, but I'm just adding it in case you're leveraging this and you don't have CUDA or a GPU, then it will work for you. So this is if an NVIDIA GPU is available with the correct driver. So I have a single GPU system working with. Now, if you have it, or if it's available, we're going to set up our bits and bytes. This only supports NVIDIA CUDA. So if you don't have NVIDIA CUDA, this won't work. This creates a configuration object that will later be passed to the Hugging Faces auto model for casual LM, the function from pre-trained, because we're using a pre-trained model. All right, so we're going to use flag for using. We're going to set the flag for using 4-bit quantization, which is memory efficient, and this enables 4-bit quantization. This significantly reduces the VRAM compared to 16 or 8 bits. I'm low on memory, so I'm making it as low as pretty low. This next parameter stands for normalized float. Normalized float 4. It's a more accurate quantization format developed by Bits and Bytes. The Bits and Bytes team preserves more precision than previous 4-bit scheme, which is lend itself for better accurate results. And what we're going to do next is we're going to tell Bits and Bytes to do computation in float 16. Even though the weights are stored in 4 bits, this is a good balance between speed and accuracy on a modern GPU. Feel free to experiment with these. Alright, so next I'm going to enable double quantization. Okay, and what this means, one layer of quantization is applied to another. A form of compression. This is a form of compression on compression, improving the memory usage without drastically hurting the performance. All right, so let's set the weight to be, let's set the weight to be false here, and then we're gonna enable proper GPU offloading. Now, this allows for me to use offload to the CPU, so this will enable proper CPU GPU offloading. Although I'm using the 4-bit, this flag is still applicable for some mixed modes. Right, so between CPU and GPU. It offloads some operations to the CPU in FE32, and this helping fit large models when GPU is limited, which it is for me. Okay, and then we're just gonna set a threshold of 6.0. As I feel free to play with these numbers. These just work for me for this walkthrough. And I'll just print out this config here, so you can see what it looks like. All right, else that's not available. If there are no GPU and only CPU. Then I'm just gonna set that to null, and I'm gonna just raise an error. For me, this error won't happen because I'm on the GPU. But for you, if it happens, at least you know why. Depends on where you're at learning this. Okay, so let's load the pre-trained model. Now we're going to use Hugging Face's API here. We're going to load the pre-trained model. So this uses the Hugging Face APIs to load the pre-trained model for casual language model, which is next token prediction. This class here automatically picks the correct underlying model class, example llama for casual LLM, and this is based on the model's config. So if you go over to the API documentation in Hugging Face, straightforward, you will see the list of supported classes. So this function, what it does, it will download the model weights, tokenizer config, and model architecture, then build the model object. All right, so here I'm going to tell it the model name, which I defined earlier, and the model I'm using is a Hugging Face model, a model that is stored in Hugging Face. You can specify something locally, but this is the one I'm going to be using. And that's the idea of the model. All right, remember we did our quantization here, so now we're going to pass that quantization, the bits and bytes config object for quantized loading. This will help me to load large models onto my small GPU by reducing memory usage, and we went into detail with that. All right, so we already added the code on to determine whether if I have GPU or not, and then I'm going to trust remote code. So this allows execution of custom Python code from the model repo. So be careful, only use that if you trust the source. Now, just in case, this here, you can pass it this parameter here, set this parameter to whatever your Hugging Face key is. So it'll be something like Hugging Face and then some. I already set mine in my .env file, and in doing so, I don't need that because I loaded that in my environment. Okay, so if you run it, you get permission issues. That is because you didn't pass it here, that parameter, or you didn't set it in your environment. So just a heads up on that. I don't need to set it because I already passed it in my environment. All right, so let's go and set